This is the session 4 for the module 1 of the earthquake engineering. In this topic, it will be going to study about the earthquake ground motion characteristics. You can see the figure. So here in this figure, it's represent the typical earthquake ground motion. It is a graph of the ground motion such as acceleration, velocity or displacement of the ground with respect to time during the earthquake. As the P waves travel faster, they arrive early at the location. S waves and body waves arrives late and will create more violent the shaking. Further, the surface waves are generated at the surface only after S waves arrives and provide combinations of the wave motion. The shaking will be the most violent at this instant. This period of violent of shaking is called as strong ground motion. It is during this period most damages takes place. Hence, for a civil engineer, strong motion part of the ground motion is very important, as the damage should be takes place within this period, and if the structures are saved during this period, perhaps the structures will never experience any problem due to earthquake. It should be noted that no two this one earthquake ground motions are similar. So whatever the figure is there, so here you can see it that there is no such similarity what we can see it. Even the ground motions are two different places under the same earthquakes are even different also. So this can be seen it from this figure, and here some the whatever the ground motion parameters are there, so they are necessary for the seismic analysis. So for that, let us see that they will provide the parameter necessary for the design, and also they help for assessing the magnitude of the damage of the earthquake they are causing. So let us see that the whatever the ground motion parameters for the seismic analysis. The first one is amplitude parameters. So in this amplitude parameters, it includes the peak acceleration, peak velocity, and the peak displacement is concerned. Now, as far as the second part is concerned, it is related with the frequency content parameters. So in the frequency content parameters, it covers the includes the ground motion spectra, then spectral parameters, and also the ratio of the whether the velocity maximum or the acceleration maximum are concerned. And next last one is the duration of the ground motion. So this is all about the whatever the seismic parameters which are concerned to the ground motions are considered. Now let us see the next part is the seismic zone map of India. So as far as the seismic zoning map of India is concerned, so India is very seismically active and has experienced many earthquakes in the past. More than 60% of our country is considered to be seismically active regions. Based on the past experience, geologic activities, presence of the active faults, and closeness to the plate boundary, the country is divided into 4 zones. You can see it in the figure. So 4 colors are there, means that is indicates the 4 zones. So zone number 2, which is a blue in color, zone number 3, whatever it is there, it's the yellowish color, and then followed by the zone whatever the 3 is there, and zone 4. So like that the different colors are there. Red is zone 5. So here the Z2 is seismically least active, whereas the zone 5 is seismically more active. in seismically very active zones, the frequency of big earthquake and possibility of the strong shakings are more over the years. Indian codal provisions are involved with the following the important modifications in the recent versions 1893. Whatever this figure is there, it is the IS code 1893 part 1 of 2016 version. So here in this figure you can see it that whatever the figure is there. So here it's a map of India with a different seismic zone, and here as far as our Karnataka state is concerned, is a seismically quite stable, and most part of is belongs to zone 2 only. Only the coastal Karnataka and some parts of north are in zone number 3. The seismic zone maps are revised time to time. You can see it that whatever the revision is there, it is done from time to time, and as more understanding is gained on the geology, the seismotectonics and seismic activities in the country. The Indian standard provided the first seismic zone map in 1962. You can see it, the serial number 1 is a 1962, and it was later revised in 1967, 1966 as well as 1970 and 1975, 1984, 2002 and 2016. So like that the different whatever the zonation map is there. So let us just go through the this one, the whatever the serial number 1 is there, it's IS 1893, that is 1962. So which is of having 7 zones. So that time the whatever the seismic zonation map of India is there, it's zones from 0 to 7, where 0 indicates no damage and 7 indicates 6 indicates extensive damage. So like that 7 zones were there ranging from 0 to 7. And again in 1966 same was just reviewed, means whatever 0 to 7 was there, so some earthquakes happened in between. So they give us the guidelines that the modifications for the changing the zone. Then according to that in 1966 the zoning map was revised, and again it has been revised in 1970. The whatever the zonation map is there, it's underwent the major revisions after 1967 Koina earthquake. So Koina is a place in Maharashtra where it is famous for Koina Dam. So which was this one epicentral location in 1967 earthquake. So later on it has been instead of 7 zones, it has been modified into the 5 zones, and zone number 1, 2, 3, 4, 5. So like that 5 zones were there. So what happened in the sense, the 0 whatever the zone was there, it is merged with the 1, and the whatever the 6th zone was there, it is merged with the 5. So like that 5 zones were made. And in between again 1975 and 1984 again the code IS code has been revised, and according to that the zoning has been relocated for the zone number 1, 2, 3, 4, 5. So like that the 5 zones were there. But in 2002 what happens, so whatever the zone maps were there, so the zone number 1 is merged with zone number 2, and so only the 4 zones were there starting from zone 2, 3, 4 and 5. So what happened means in 1993 again in Maharashtra, Latur earthquake has given indications that the zonation map is to be again get revised. Now the whatever the latest the earthquake zonation map is there, it is as per the latest IS code book, that is 1893 2016. The zone map was again revised after the Bhuj earthquake which has taken place in 2001. So here again the whatever the map which we have seen, it is from 2016 IS 1893, and here only 4 zones are there, starting from zone 2, 3, 4 and 5. So here, as per as the codal whatever the 1893 is there, so table number 3 is gives us the seismic zone factor. So how this seismic zone factor is to be considered. So now, as per as the zone 5 is there, which will covers the area with the highest risk of suffering the earthquake intensity is a little bit greater, and whatever the IS code is there, which assigns the zone factor as 0.36. You can see it in a table for the zone 5. The structural designer used this factor for the earthquake resistant design of a structure in zone 5. The zone factor is 0.36. That is the maximum horizontal acceleration that can be expected by the structure, and is indicative of the effective zero period level earthquake in this zone. It is referred to be a very high damage risk zone. The regions of this zone 5 as per the latest code is belongs to regions of Kashmir, western and central Himalayas, north and middle Bihar, northeast India regions, and the run of the Kutch and Andaman Nicobar groups of islands will fall under this zone. And generally the areas having the trap rock or a basalt rock, they are prone to the earthquakes. So now let us see about the zone number 4. So as far as the zone number 4 is called as again high damage risk zone, and which will cover the whatever, if you say it, the intensity scale, so it is up to 8. The whatever the IS code is there, its a zone factor is given in this table as 0.24 for zone 4, and in this zone 4 it covers the Jammu and Kashmir region, Ladakh, Himachal Pradesh, Uttarakhand, Sikkim, parts of Indo-Gangetic plains like North Punjab, Chandigarh, Western Uttar Pradesh, Tehri, then North Bengal, and the Sundarbans areas. The capital of the country, even Delhi, falls under the zone number 4. In Maharashtra, the areas like Patan, where the Koina region is there, so it is also in zone number 4. In Bihar, the northern part of the state, in this area such as Raksal near the border of India and Nepal, is also comes under zone number 4. Now let us see about zone number 3. Zone number 3 is classified as a moderate damage risk zone, which is the whatever the intensity scale, it is around 7. The whatever the IS code, they assign the zone factor as 0.16 for zone number 3. Several regions like mega cities like the Chennai, Mumbai, Kolkata, and Bhubaneswar are lies in this zone. And now talk about the zone number 2. So zone number 2 is in this region is the intensity scale is around 6 or lower than that, is classified as a low damage risk zone, and even in the IS code also it is zone factor is considered as 0.1 for the zone, this zone. Whereas the zone anyway up to zone 2 is there is no zone 1 is there. So because already in the revision of the course the zone whatever 1 was there, it is merged in the zone 2 only. Now whatever this table is there, which is provide the details of the zone factors for the different zones, and it can be seen that the zone factor is 3.6 bigger in zone number 5 than in zone number 2, means first to last. So how much it is there? So it is 5 times more. Hence the horizontal forces is 3.6 bigger in zone 5 than seismically least active places. So this is all about the zones are concerned. So now here we have to see the some few important things from this is the design based earthquake and maximum credible earthquake, that is called as design based earthquake is called as DBE, and the maximum credible earthquake is called as the MCA, or the two level of the ground motions which are considered in the design. So DB refers the most probable earthquake a structure might experience several times during its lifetime. Under this earthquake, the structure should not experience total failure. Hence, the structure is designed under DBA is experience only non-structural damage and should be brought back to the normalcy without serious problems. The design under this earthquake is called as a level 1 design. The structure should be safe against this earthquake load. Further, the whatever the MCE is there, it's referred to the unexpected earthquake which the structures may or may not face during its lifetime. Whereas MCE stands for the maximum credible earthquake, which is maximum the shaking that can be predicted statically based on the history and the probability of the occurrence in future. Hence, if the earthquake unfortunately strike, care is necessary to reduce the damage. At the same time, there is no rationale in designing the structure to be safe against this earthquake, which means highly uneconomical design. Therefore, the design under MCE is called as the level 2 design, and which focus on imparting ductility to the structure. The ductility of to the structures will be enough warning before the failure. The level 2 design will allow the structures to have a significant ductility such that even under a bigger earthquake, structures should provide the sufficient time before the collapse. The best design is in this which the occupants can come out of the building and see how the structure is falling. Hence, the concept of different level of the design is very extremely important in the earthquake resistance analysis. Hence, MC is much bigger than DBA. Even in IS 1893 code book also, the level of acceleration is considered as MC is twice as the DBA. So this is all about the whatever the ground motion characteristics as well as the seismic zonations and the two important design parameters like is DBA and MCA.